think we will start with the lecture. Okay. So yesterday last time we were discussing about the thin film sensors, and we have seen that thin film sensors are produced by directly depositing material onto a substrate in a vacuum deposition chamber, and this process is called as sputtering process. So this sputtering process allows to control the films. Okay, and it also produces good degree of repeatability. So that is what is advantage of this type of sensor. Now here you can observe the various methods those are used to fabricate the thin films. Okay, so the thickness of thin film sensor is of the order of nanometers, okay, to several micrometers. So this is the range, and you have to remember this. And there are different methods of producing such type of sensors, which are chemical vapor deposition, physical vapor deposition, molecular beam epitaxy, atomic layer deposition. Okay, so these type of coating techniques are used. The materials which are used to fabricate such type of sensors, it may range from polymers to oxide complexes, thermoelectric materials, and even to silicon based materials. So you have to remember materials which are used to fabricate the thin film sensor. So this is what is important for your examination point of view. So various types of sensors are fabricated by using this thin film technology. And first class of sensors that is fabricated with thin film technology, as you can observe in the picture. These are gas sensors which are used to determine the concentration of various gaseous molecules, or even VOCs. VOCs means volatile organic compounds in an environment. Okay, so they are used to detect gases like nitrogen dioxide, ammonia, ethanol, etc. Okay. What is advantage of thin films is that they have high surface area, and for gaseous molecules, this surface area uh, makes it to bind to its surface, and what is called as adsorption of the gas molecules to the greater extent can occur at the surface of the thin film sensor. Okay, so this adsorption of gas molecules at the surface of the thin film sensor is going to change the conductivity of a particular material. And this conductivity of material, or what you can say is amount of electrons, which are free electrons, which are present in that particular semiconducting material, it depends on the concentration of gas that is adsorbed to the surface of the film. Okay, so as conductivity changes, the resistivity of the material changes, and this change in resistance is measurable, and this can be measured with the help of various types of signal conditioning circuits. So very simple signal conditioning circuits are required for this, and particularly voltage divider type of signal conditioning circuits are used to convert the change in resistance to change in voltage, because change in voltage can be measured accurately, and it can be calibrated in terms of the concentration of the gas. Okay, so this is all about gas sensors. One more thing you can observe here, this picture shows what is called as a strain sensor. Okay, So whenever you apply a stress to the material, then strain is produced in that material. And if you can measure this strain, then you are able to measure weight that is applied. Okay, even you are able to measure the pressure. Okay, so basically thin films are suitable for such strain sensors. Here in the figure you can observe metal type of strain sensor, and suppose if you apply a stress to this material, a strain is produced into the material, and that will cause elongation of this metallic wire, and reduction in the diameter of the wire. And as you know, resistance of metal is proportional to area of inversely proportional to area of cross section and directly proportional to the length of wire. So if strain is applied, if strain is produced in the material, and this causes deformation of the material, and this deformation of the material causes change in resistance, because R is equal to rho into L upon A. This is what is we have studied, where rho is constant, specific resistivity of the material. It depends on a particular material. So it remains constant for a given material. So if you apply stress and strain is produced, then resistance will be proportional to length and cross-sectional area. And strain is proportional to, again, this length and cross-sectional area. And in this way, strain will be proportional to resistance of the material. Okay, so here also generally the strain is converted into change in the resistance. Okay, and this change in the resistance in case of strain sensors is measured with the help of signal conditioning circuit like resistive bridge. So this strain sensor forms one of the arm of the resistor bridge, and imbalance in the resistor bridge can be measured in terms of the strain. So here again, the current flowing through galvanometer can be calibrated in terms of strain. Okay, even this current can be converted to voltage with help of operational amplifier, and directly voltage which is proportional to strain is available at the output of such type of sensor, and that can be calibrated with help of it can be calibrated in terms of strain. Okay, so this is what is about the strain sensors, and such type of strain sensors they are used in weighing machines. Okay, electronic weighing machines, all of you know, and you are using it, and in such weighing machines the strain sensors are used. The material which is used for strain sensors, either it is metallic or it is semiconductor. So semiconductor strain sensors are more sensitive as compared to metallic strain sensors, because the change in the resistance which is produced in semiconducting material, it is of greater extent as comparable to this. Okay, so as you can see, if you are using these type of sensors in thin film technology, then it becomes possible to add such a type of sensors in wearable devices. So wearable devices are quite widely used nowadays. Okay, so you are using some fitness device in your hand. So these type of devices, they are called as wearable devices. Okay, now 1 minute. Now after strain sensors, we'll be discussing about heat flux sensors. So heat flux sensors, they can be made with the thin film technology. So different types of heat flux sensors are available, and basically they are of two types. One is called as RTD, that is resistance temperature detector. Here also metal heat element is used as a sensor, and resistance of the metal changes with respect to heat applied to it. So when heat is increased, the resistance of the metal increases. Okay, so this property is used. This property of metal is used in order to convert change in temperature to change in resistance. And again, this change in resistance can be converted into change in voltage, and it can be calibrated in terms of temperature. But this type of RTDs are very suitable to be fabricated using thin film sensors. Okay, because we want to deposit metal, and metal can be deposited very well by using this thin film technology, because the fabrication technology is best suited for the metals that are to be deposited onto the substrate. So very thin sensor can be fabricated with help of this, and advantage of thin sensor is that its surface area is increased, and due to which the sensitivity of the sensor it increases. The sensor becomes sensitive, and your measurement becomes reliable. Okay, so that is what is the thing that can be achieved with help of this. Along with RTD, thermocouple type of resistors can be sensors can be fabricated with the help of thin film technology. So in thermocouple type of sensors, again bimetallic wires are joined together at two ends. So that is what we have seen. So this is again suitable to be fabricated in thin film form, because again metal is used here. So if you fabricate this in thin film form, then the EMF which is produced across such a thermocouple will be more as compared to your simple wire type of thermocouples. And therefore um, array of these thermocouples, which are called as thermopile, they are used, or they are fabricated in thin film type of sensors, and they are used to measure the temperature. Okay, so here again the sensitivity is important factor, and that can be increased by forming the pile. Pile means arrangement of number of thermocouples. They are connected together to form a pile, and that pile will increase the amount of the voltage which is produced, so which increases the sensitivity of the sensor. So this is again suitable, and most thermopiles and RTDs, they are fabricated by using a technology called as thin film technology. Okay, now next type of sensor, what you can see is a humidity sensor. Humidity sensor is used to measure the amount of the uh, humidity, that is water content, which is present in the environment. Okay, so these water molecules can be detected by semiconducting material or even polymers. Polymers are suitable for this. And what happens, the water molecules, they adsorb to the surface of the sensor, and they produce the change in conductivity or resistivity of the thin film, just like your gas sensor. Okay, so generally relative humidity is measured of the environment, and the sensors which are formed for humidity measurement, they are again suitable to fabricate in the form of thin film sensors. Here you can observe how that particular sensor can be fabricated. The substrate is taken, and over the substrate electrode is deposited, and then thin film polymer is deposited, and over that upper electrode is deposited, and two terminals are taken out from upper electrode and lower electrode, which are forming contact. Okay, so again here, as you can see, as you are fabricating the sensing material by thin film technology, which is going to increase the surface area and thereby increasing the sensitivity of the sensor. Okay, now here you can observe thin films can also be used to sense the multiple parameters. Okay, and these multiple parameters can determine whether some coating has been degraded or corroded, okay, even at early stages. So uh, these sensors can measure multiple parameters like temperature, moisture, pH, chloride content of the coating, and its surrounding environment. So by measuring all these parameters, it is possible to determine the corrosion time of the coating. Okay, and such corrosion time is predicted by the manufacturer. Okay, so detecting the corrosion is important thing in industry, and that can be carried out with the help of thin film sensors. Okay, so as you can see, these sensors use basically electrochemical mechanism to see if any oxidation or reduction has occurred in that coating. Okay, this produces a current, and that is linearly proportional to the gases byproduct of these reactions. Okay, so this oxidation and reduction, it is going to produce gaseous byproduct, and this gaseous byproduct can be measured to measure the amount of corrosion that has been occurred. So here you can observe in industry various components, various blocks, they may be subjected to corrosion, and that need to be detected, and that can be detected with help of such type of corrosion sensors. Now, yeah, why the thin film technology is advantageous? So that is what we want to discuss. Okay, so it has simple fabrication, uh, it occurs at a relatively low temperature. Okay, so this is another advantage, and less material is required because its dimension is smaller, and as this is thin, it is flexible and non-breakable, and so it is suitable for wearable devices also. So high output can be obtained because it has greater sensitivity. Okay, so uh, these are some of the important things or advantages which you must know about the thin film sensors. Okay, now after this we are going to discuss the another class of sensors which is given in your syllabus, and that is nano sensors. Okay, so nano means 10 to the power of minus 9. Okay. So nano sensors are chemical or mechanical sensors. Those can be used to detect uh, basically presence of chemical species and nanoparticles, or monitor physical parameters such as temperature on nanoscale. Okay. So uh, they also find application in medical diagnostic application. Okay. Nanosensors have been developed to the point of measurement at a single molecule level. So these are extremely small devices capable of detecting and responding to physical as well as chemical stimuli. So both type of sensors are there. So any one of the dimension of the sensor or the material used to fabricate this, if it is of the order of nanometer, then that type of sensor is called as nanosensor. So here you can see one example of this. Okay, so in industry, the current nanosensor devices which are available, they are uh, nano sensors which are formed with the help of what is called as porous silicon. Nanoparticles are used to fabricate sensing device. Nano probes are used. Nano wire nano sensors are used. That means the particles in the form of nano wires are used to fabricate the sensing element. Okay, so these are certain current nanosensor devices which are available in the industry. Now here in this picture you can observe what is called as nano probe. Okay, so uh, this is a nanosensor probe, and this particular nanosensor probe is carrying a light. Okay, and it is carrying a blue light, and it penetrates a living cell to detect the presence of a product. Okay, and that presence of the product is going to detect whether this is a cancer causing substance or not. So for such medical reasons, the nano sensor probes are used. Okay, so here one more thing you can observe, another type of nano sensor, that is nano bio sensor. This is chemical or biological sensor, and this responds to varying concentration of a single analyte or a specific class of chemicals, and it is going to convert these analyte into some change in electrical property of that material. Okay, now here, as you can observe, there are two types of nanosensors based on sensing mechanism. One is called as mechanical nanosensor and another is called as chemical nanosensor. Okay, and both have different sensing mechanisms. Nanosensors which detect chemical by measuring the change in electrical conductivity of the nanomaterial. Okay, so such type of sensors are called as chemical type of sensors. Okay, so many nano materials, they have high electrical conductivity, and which will reduce upon binding of such chemical molecules after adsorption of that particular uh, molecule to the surface of the sensor. So if a sensor is exposed to certain chemicals, these chemical molecules, they adhere to the surface of the sensor, and this adherence of molecules to the surface of the sensor changes the conductivity of the nanomaterial, and this change in conductivity of the nanomaterial can be calibrated in terms of concentration of chemical which is attached to its surface. So such type of nanosensors, they are called as chemical nanosensors. Okay, now going to second type, mechanical nanosensors. They work by detecting change in, again, electrical conductivity of the material, but here the mechanism is different. Okay, so here what happens, there is a change in electrical conductivity when the material is physically manipulated. Okay, so this physical change which is applied to the sensor, it produces a detectable response, and this detectable response, again, most of the time it is a change in the resistance, but sometimes it may be change in the capacitance also. So this creates a measurable change, and which can be measured, and thus some physical stimulus can be converted into electrical signal with help of mechanical nanosensors. Okay, now here you can see the diagram how the sensors work. Okay, now let us see what is this. This is target analyte. Analyte means the thing you want to detect. Okay, and this is a recognition element or receptor element, that you can call it as. To this, the analyte is attached, and this again will go to next process which is called as transduction process. So this provides sensing, and after that second process occurs which is called as transduction process, and this transduction process is going to convert uh, change in some physical parameter or chemical parameter to electrical parameter. Okay, and this electrical change is converted into a proper signal by data processing, and measurable output signal is produced. So this is what is happening in nano sensor. Okay, so here, as you can see, the same thing which I have discussed earlier, the same thing is given here. So we can go ahead. Now let us go to application of nanosensors. So number of applications of nanosensors are there. Optical nanosensors, uh, they are also available. Okay, and nanosensors which are used to monitor environment. Okay, so various types of gases which are hazardous, those can be monitored with help of this. At the same time, toxic chemical compounds which are found in environmental samples, they can be detected with help of this type of sensors. Even as you can say, see here, a trace of amount of metals, okay, which are hazardous metals, even nitrates, phosphates, pesticides in waterborne samples can be detected with the help of nanosensor. Okay, so now then you can observe here. Many applications focus on the detection of various molecules in certain environment. Okay, they can also be used to detect the electromagnetic radiation. Okay, so it is used to detect ultraviolet radiation at low levels. So some such type of sensors are also available. Okay, now there is a growing trend of combining these nanosensors with other useful technologies. For example, uh, take an example of MEMS, micro electromechanical systems, and microfluidic devices. Uh, this includes deposition of nanoparticles, and combining nanotechnology with this MEMS technology has been provided advantageous to detect various type of samples. It finds application in medical field, okay, to detect the cholesterol in blood sample. So this is one of the application of sensor which is using hybrid technology, that is combining nanotechnology with some other technology. Okay, so here in short you can see why nanosensors are used to detect various chemical in gases for pollution monitoring, for medical diagnostic purpose, to monitor physical parameters such as temperature, displacement and flow, to monitor plant signaling and metabolism, to understand plant biology, to study neurotransmitters in the brain for understanding neurophysiology. So, a wide range of applications are there. Now, what are the advantages of these type of sensors? That is very important as far as your examination is concerned. They provide greater sensitivity and specificity. Okay, this is one of the very important advantage of the nano sensors, and they provide better real-time monitoring as compared to traditional detection methods. So they are becoming popular nowadays. Okay, so with this we are completing our chapter number 3 here of paper number 1. So this chapter was little bit descriptive, but it is small chapter. So we have finished up it earlier. So after this, we are going to discuss third chapter of paper number 2. Okay. And third chapter of paper number 2 is basics of computer organization. So first we will do that, and afterwards we'll come to fourth chapter of your even paper. And fourth chapter of the even paper is operational amplifier. So which will be our last chapter. So that can be done very quickly. So don't worry about that. So from tomorrow we'll start with the basics of computer organization. So in this basics of computer organizations, you are going to study block diagram of computer system, block diagram of central processing unit, and different architectural features of computer system. That is what we are going to study. We are going to study register organization, which is present within the central processing unit. So this will be the first architectural point of basic computer organization. And second architectural point is we are going to study stack organization. Stack is a special type of memory which is used in computer system. It has some different types of uses, and how this stack is organized and how it is operated in computer system. That is what we are going to learn there. And after that, we are going to study about input output organization. Okay, if we want to interface external device to the computer, then what kind of intermediate circuitry is required between your computer and external device. Okay, so this is called as input output organization, and this input output organization we are going to study, in which we are going to study what is input output interface, generalized block diagram of input output interface we are going to study. Okay, so that is what is important as far as your uh, syllabus is concerned. Okay, and fourth chapter in this is memory organization. Again, it is easy as compared to basics of computer organization. So I have given you two assignment. One assignment is to find information about the sensors which are present in your mobile phone. So you have to find electronics behind it, and handwritten assignment along with the pictures pasted you can submit. And second assignment is about the different types of memories which are used in computer system. So those you can find from internet, different type of technologies, different type of memories using different type of technologies like semiconductor memories, like your hard disk drives, optical memories, uh, pen drives, flash memories. So these are various type of memories. So collect information about that. Again, this should involve electronics in it, and this again should be handwritten. You can paste pictures to it. Okay. सेकंड असाइनमेंट ही टाइप्स ऑफ मेमरीवर इन्फॉर्मेशन कलेक्ट करून लिहायची आहे. सेकंड असाइनमेंट ही जी आहे टाइप्स ऑफ मेमरीवरती इन्फॉर्मेशन कलेक्ट करून लिहायची आहे. ओके, आलं लक्षात?
येस मॅम.
हा, आणि आपलं प्रॅक्टिकलची असाइनमेंट राहिलेली आहे ते मी उद्या बोलेल त्याच्याबद्दल. हा, आज बऱ्यापैकी कमी मुलं दिसत आहेत मला प्रेझेंट का मीटिंग. ओके, मी आता मीटिंग एंड करते. उद्याला नवीन चॅप्टर आपण चालू करू.